The Chinese have announced that they're going to go to the moon. In fact, they will probably beat the United States. For centuries, the moon has fascinated and inspired us. It's a place of mystery, wonder, and endless speculation. But what if we told you that everything you've been taught about the moon's origins, its composition, and its true purpose might be completely wrong? In a stunning new research finding, renowned physicist and futurist Dr. Michio Kaku has made an extraordinary discovery about our celestial neighbor that will challenge the very foundations of our understanding. But what surprising revelations has Kaku uncovered this time around? And how does this challenge our traditional beliefs and knowledge about the moon? Join us as we embark on a mind-bending journey with Kaku to explore why the moon is not what you think it is, unravel hidden lunar wonders, and uncover astonishing discoveries that defy all expectations. It's fascinating to think about why we haven't returned to the moon since 1972. The Apollo 11 mission in 1969 was extraordinary when humans first landed there. But things have changed, and advancements have made a lunar mission more feasible. A renowned scientist, Kaku has recently shared his thoughts on efforts to recreate that historic feat. China has taken a noteworthy step by sending a robotic spacecraft to collect lunar samples. This development adds intrigue to the ongoing lunar exploration saga. Meanwhile, Michio Kaku extended his congratulations to China for this remarkable achievement, emphasizing that they have now become the third country to accomplish this feat, following the United States and the Soviet Union. It's intriguing how they seem to be emulating the United States' footsteps, while taking shortcuts to make impressive progress. What's even more fascinating is the perspective shared by Michio Kaku, who believes that although we may not have a traditional space race like in the past, it's still crucial to consider the military implications of space exploration. He wisely points out the potential sinister motives that could emerge as frequent visits to the moon become more common. In this regard, major powers such as Russia and China are actively developing hypersonic drones, which are rapidly becoming the preferred choice of weaponry. In Kaku's opinion, the moon itself doesn't hold significant military value, since it takes only a few days to reach it. This realization sheds light on the deeper strategic aspects of space exploration and the potential military implications it may bring. However, the race for advanced weaponry on Earth, particularly the development of hypersonic drones, raises legitimate concerns. This is where the United States Space Force comes into the picture. Initially, some people may not have taken its establishment seriously, but upon closer examination, it becomes evident that it serves a crucial purpose. The U.S. controls over half of Earth's satellites, which are crucial for protecting our economy and communication systems. The Space Force safeguards these assets, recognizing the importance of space defense. However, it's important to avoid an uncontrolled arms race. Michio Kaku also highlights covert U.S. moon exploration efforts. Now, let's explore the role of private individuals in space. Elon Musk and Jeff Bezos, two visionary entrepreneurs, are likewise advancing space exploration. Musk aims to establish a multi-planet society, expanding human presence beyond Earth. Meanwhile, Bezos envisions Earth as a pristine park, moving heavy industries to space for a cleaner planet. Both embrace space's resources and potential. Differing views on space's future add intrigue. The private sector drives innovation, shaping human presence in space. Private involvement sparks cosmic fascination. Elon Musk sells lunar tourism tickets, making a moon honeymoon a possibility. Mind-blowing prospects for our grandkids. Space exploration is bustling with activities. China's lunar missions, military implications, U.S. Space Force, and private aspirations shape the future and expand our understanding of the universe. Reaching the moon has little military value. Conflicts on Earth unfold faster. Yet, hypersonic drones raise concerns as favored weapons. Russians claim operational hypersonic weapons, outpacing the U.S. Chinese are actively pursuing the same technology. Now, a strange discovery has gripped their attention. Researchers confirm water exists in tiny glass beads scattered on the moon's surface. China's Chang'e 5 lander made this groundbreaking find during its successful mission, leaving everyone puzzled. Imagine the excitement that followed when these water-filled beads were carefully collected and examined. The findings of this remarkable study, published in the prestigious Nature Geoscience journal, have cast a radiant light on the enigmatic nature of lunar water. Moreover, they have sparked a wave of curiosity and anticipation regarding the implications of this discovery for the future of space exploration. As a result, a team of dedicated researchers embarked on an extraordinary journey of scientific exploration, meticulously examining a remarkable collection of 117 spherical glass beads. These precious artifacts were handpicked from a lunar soil sample ingeniously collected by the robotic arm of the Chang'e 5 lander during its ambitious lunar mission. These intrepid scientists delved deep into the secrets of these lunar treasures by utilizing cutting-edge techniques such as field emission scanning, electron microscopy, electron probe microanalyzer, and Raman spectroscopy. What they unveiled was truly remarkable. With utmost precision and skill, they confirmed the presence of water concealed within these remarkable glass beads. For countless years, scientists have tirelessly sought to unravel the mysteries surrounding the presence of water on the moon. Their quests aim to understand its origin, distribution, and the fascinating ways it has evolved within the lunar regolith. According to the esteemed Michio Kaku, these recent discoveries make a substantial contribution to our ever-expanding knowledge of lunar water. This newfound understanding holds remarkable significance for future explorations of the lunar surface. It enhances our comprehension of water reservoirs on celestial bodies devoid of an atmosphere within our solar system. The extraordinary Chang'e 5 mission, launched in December 2020 by China, marked a pivotal milestone in lunar discovery. The primary objective of this mission was to retrieve the freshest lunar samples ever obtained and safely transport them back to Earth. Equipped with a remarkable robotic arm, the Chang'e 5 lander successfully accomplished this feat. The presence of water in these glass beads enhances our knowledge of the moon and opens doors to further exploration. Exciting revelations lie within the prestigious journal Nature Astronomy, unveiling a captivating understanding of our lunar neighbor evolving right in front of us. Travel back in time to that breathtaking moment when the Apollo astronauts first stepped foot on the moon's surface. The moon was widely believed to be a barren wasteland with no signs of water. However, the rocks they brought back held a mysterious secret, hinting at the existence of water. Unfortunately, these groundbreaking findings were dismissed as contamination, dampening our thirst for knowledge. But now, a paradigm-shifting revelation has rekindled our curiosity. Water does, in fact, reside on our celestial neighbor. This astonishing revelation transforms our understanding of the moon's makeup and opens up exciting possibilities for future exploration. As the veil of mystery lifts, we focus on the discovery of a precious gem, a new lunar mineral that promises to reshape our lunar knowledge. These lunar samples obtained during the Chang'e 5 mission breathe new life into our understanding of the moon. They are like time capsules, holding vital information about the origin and history of the moon and our planet. As the quest for clean and sustainable energy intensifies, the allure of helium-3 continues to grow, driving innovation and shaping the future of energy production. The valuable discovery of helium-3 on the moon has ignited a race to mine this resource, ushering in a new era of competition among nations and organizations. This development holds the key to a cleaner and more abundant energy future. In the area showed unusual geometric shapes reminiscent of structures that could have been formed by intelligent processes. While these formations could be explained by natural geological forces, their symmetry and orientation raised eyebrows among the scientific community. Could they be remnants of artificial structures buried beneath the Martian surface? One of Perseverance's key tools, the Sherlock instrument, is designed to detect organic molecules. It began to analyze these curious formations, and what it found added more fuel to the fire. The instrument detected complex organic compounds embedded in the rocks. While organic molecules can form through natural processes, their complexity and concentration suggested a possibility that life or even advanced processes might have been involved. NASA remained cautious in its announcements, emphasizing that more data was needed. However, behind closed doors, discussions began to escalate. Some scientists wondered if Mars could have hosted an ancient civilization millions or even billions of years ago. Adding to the intrigue was the data from Perseverance's companion, the Ingenuity helicopter. During one of its flights, Ingenuity captured images of what appeared to be rectangular patterns etched into the Martian soil. These formations, spread out over a large area, bore a striking resemblance to archaeological sites on Earth. The images ignited speculation. Could this be evidence of an ancient Martian settlement? Or was it merely a strange quirk of Mars's harsh winds and weathering? Mars's ancient atmosphere was far different from the dry, thin air we see today. Billions of years ago, the planet likely had a thicker atmosphere, liquid water on its surface, and a magnetic field protecting it from solar radiation. These conditions could have supported microbial life and perhaps even more complex organisms. The discovery of methane plumes on Mars has long puzzled scientists. Methane is a gas that on Earth is primarily produced by biological processes. While it can also be generated by geological activity, the episodic release of methane on Mars has been difficult to explain. During its mission, the Curiosity rover detected spikes in methane levels, and Perseverance followed up with additional measurements. What made these findings particularly intriguing was the timing. Methane releases seemed to occur in a pattern, as if triggered by some underground activity. Could this methane be evidence of subsurface life, perhaps remnants of a long-lost ecosystem? Or is it a product of geological activity tied to Mars's ancient past? Perseverance's mission is also closely tied to understanding Mars's water history. Evidence suggests that Mars once had vast oceans covering much of its northern hemisphere. The remnants of these ancient seas are preserved in the form of dried riverbeds, deltas, and salt deposits. In one area, Perseverance stumbled upon something unexpected: traces of what appeared to be ancient mining activity. The rover's instruments detected unusually high concentrations of certain rare minerals in a localized area. The arrangement and distribution of these minerals didn't match natural geological processes. Instead, they suggested deliberate extraction and refinement. But who or what could have been responsible for such activity? Some researchers speculated that this could be evidence of natural resource utilization by an advanced Martian society. While there's no direct evidence of such a civilization, the possibility opens up new avenues of exploration. If intelligent life did exist on Mars, it may have left behind clues buried beneath layers of sediment. The most compelling piece of evidence came from Perseverance's core samples. As the rover drilled into the Martian surface, it extracted cylindrical samples of rock and soil for analysis. One sample, in particular, caught the attention of scientists back on Earth. Embedded within the rock was a small, irregular structure that resembled microfossils found on Earth. While this discovery alone wasn't conclusive, it raised the stakes. If further analysis confirms the presence of fossilized microorganisms, it would be the first direct evidence of life beyond Earth. More importantly, it would open the door to the possibility of more complex life forms in Mars's past. The search for life on Mars is about more than just understanding the planet's history. It's about understanding our own place in the universe. If Mars once harbored life, it would suggest that life is not unique to Earth. It would imply that the building blocks of life are common in the cosmos, raising the possibility that intelligent civilizations may exist, or have existed elsewhere. As Perseverance continues its mission, it's collecting samples that will eventually be returned to Earth. This sample return mission, scheduled for the 2030s, could provide definitive answers to some of these questions. In the meantime, the discoveries made by the rover are reshaping our understanding of Mars and its potential to host life. The question remains: if something was here before us, where did it go? Did an ancient Martian civilization meet its end through a catastrophic event, such as a massive asteroid impact or climate collapse? Or did they migrate elsewhere, perhaps leaving behind only faint traces of their existence? Mars is a planet that keeps its secrets well. But with each new mission, we come closer to unraveling its mysteries. The findings of Perseverance and other Mars missions have already changed the way we view the red planet. They've shown us that Mars is more than just a barren world. It's a planet with a rich history, one that might include the story of life. As humanity prepares for future missions to Mars, including eventual human exploration, the search for answers will only intensify. The red planet holds clues to some of the most profound questions we've ever asked. Are we alone in the universe? Or is Mars the first step in discovering a cosmic family tree? The journey to answer these questions is just beginning. Mars has much to teach us, and it may yet reveal secrets that will change our understanding of life, the universe, and everything. For now, we can only marvel at the discoveries made by the rovers and await the day when humanity sets foot on Mars, ready to uncover the truth of what came before us. The possibility that an advanced civilization once thrived on Mars is more than just a fantasy. It is a concept that continues to gain traction as more evidence comes to light. The ancient history of Mars may have been far more complex than we have ever imagined, with signs that an unknown civilization might have left its mark on the planet. As humanity's reach extends farther into the cosmos, Mars has become more than just a neighbor in the solar system. It has become a puzzle that could reveal answers to our origins. While Perseverance continues to explore the Jezero crater and its surrounding regions, its discoveries are helping us piece together the puzzle of Mars's history. These findings have started to provide tantalizing clues about the planet's past, offering a glimpse into what it might have been like when Mars had a thicker atmosphere and abundant water. Scientists now know that Mars wasn't always the cold, dry desert it is today. In fact, it may have been capable of supporting life in the past, potentially even intelligent life. As the rover collects core samples and continues its investigation, researchers are beginning to realize that the structures and patterns on Mars might not be as random as once believed. The symmetry and precision observed in some of the geological formations are starting to suggest the presence of highly advanced intelligence. This is not the kind of randomness we expect from natural forces, but rather evidence of purpose and intentionality.